Hello everyone. Now, I'm talking about your second homework right now. If you remember last week, we have taken some of your photos. Actually, there have been 17 students in the class. So we have taken more than 10 poses of each of you. I have deleted some of the poses which were quite an extreme. So we have 17 students and 10 pose of each. So in total, we have 170 facial images. And here you can see the link where you can download these face images. Now, what you have to do is this. Again, right now you will see another link. Here in this link, if you go to the MathWorks, you can download the PCA code for face recognition. It has been written for another face database. So what you need to do is you need to update the code slightly so it can read the face images that we have in here in our database. And you have to conduct the recognition rate. Now, if you look at the code works for 5 training and of the samples. So each of you will put 5 of your faces into the training, and we will have 5 of each of the pose. So if we are 17 multiplied by 5, it will be 85 faces will be tests. So we are testing and we are seeing what is the performance. Now, what I want you to do is, apart from adopting the code in a way that it can read the face database that we have in our Google Drive, I want you to first implement a code which is called Viola-Jones face detector. Now, if you look at the face images that we have, there are a big portion of background and a very big portion of things which are not really face images. And they can affect actually on our recognition rate. So what we want to do is we are applying Viola-Jones face detector at the beginning. So we are cropping the facial part. So we will get rid of many parts of backgrounds, of body, which are in there. MATLAB, OpenCV, and so many other programs that you use, luckily, have the Viola-Jones already embedded. So what you need to do, you need to search a little bit on the internet in order to see how to call and use this program. So Viola-Jones face detector is what you need to look for. Apart from that, what else you need to do? You are applying the Viola-Jones face detector. So you take the faces, and after that, you have to resize all the faces into an equal size. Remember, in PCA, all the faces in the training, test, and training sets should be of the same size. If they are not of the same size, we will get an error. Think about it. Why? Now, we have resized our images. We have to take the faces, we have resized the images, then we are applying the PCA and we are conducting the face recognition. What you need to do is, first we will have 1 training, 9 tests per sample. Then we will have 2 training, 8 tests per sample, and we continue till we have 9 training and 1 test. As we are expecting, the performance will increase as we have more number of training. Logically, we will have the better probability of guessing the correct class. Now, you will make a table and you will write down what is your results. Okay? We know maybe some of the faces are good faces, and some of the faces of one person are not very good faces. So including good faces in the training, it might be kind of biased. So what you need to also do is, we have to randomly, let's say you want to have 5 in the training, so we have to randomly pick 5. And then the other 5 will be in the test of each sample. Because we randomly pick up, we have to do it, let's say, 20 times. We have to repeat it for like 1 training, 9 tests. We have to do it for 20 times. So we can average the performance at the end. So you have to adapt the code in a way that randomly we are picking up n number of trainings per sample, and then we have to test it. Let's make it like quite general for all of us, 25 times. So we run it 25 times and we average it. Then after that, you are reporting your performance. So this will be the part which we are using the whole IM phases in order to reconstruct the images, like we can fully reconstruct it and we see the performance. After you have done this, I want you to keep the hold the steps the same, but we will keep 5 training and 5 tests per sample. Now what we do is this. You will change the number of IN phases or IN values from 1 up to the maximum. And we will see how the performance is changing. So we have only 1 IN phases in order to reconstruct till we have all IN phases in order to get the performance. So we understand if we have 1 IN value, the performance will be very low, and as we are increasing, the performance will start to increase. And we will see that there is usually a trademark at which point we say that, okay, we don't want to use all the IN phases. We will use N amount or M amount of that one, and the performance is reasonably okay. So this will be your second homework. As you can see, there are lots of parts that you need to do. I'm expecting you to do it. I will put this one today on, and today is 19th of October. It will be 15% of your project, so it's pretty important. PCA actually is very important in our course, so I give you 1 month. So by 19th of November, I'm expecting you all to submit your codes and your reports on that. So what you need to submit is this. You see lots of codes are available. You will download and use all those codes, and you will submit your codes. If you write in MATLAB, if you write in Python, but you will submit all your source codes. You will submit a Word document, or if you want to do it in LaTeX, then you submit your PDF plus your text file. And inside it, you have to put to the table what is the performance for full IM phases with 1 training till 9 training. And then you will put also a table that we cannot put a table. We will draw a graph which on the x-axis we show what is the number of IN phases that we have, and on y-axis will show the performance. Okay. So these are the 2 things that you will have in your report, and of course a paragraph about what they are doing and what was your observation. Don't forget to use the violations. So here are the link that you see for Google Drive and the link that you can see for MathWorks. I hope you will enjoy doing this homework. Be seeing you in the class.